And we are back with the fourth part of the tutorial. Just to remind, we are building a 2.5D space shooter in Godot 4, and we came to the point where it's necessary to create some enemy objects. Let's start with asteroids. In Blender, it's possible to create unique asteroids without too much effort. But before doing so, it's important to ensure that the built-in add-on called Extra Objects is activated. Let's check it, edit preferences, add-ons, and type extra. Yeah, it is. Add mesh extra object. That's exactly the add-on we need for this. Okay, so we will press A to select all objects and X to delete them. Very well. Now press Shift A, add mesh and the rock generator. Let's click this menu at the bottom left corner, add rocks, and add a preset section, click it and select asteroid. Now we have something that can be called asteroid, right? If you are not satisfied, you can experiment with these parameters, deformation, roughness, etc. to regenerate the rock and just try more models and more options. Okay, I think this is fine. So now we can see here that the asteroid is very detailed. The number of vertices is almost 50,000, which is just too much. We need to optimize performance in our game, and it's important to consider the impact on using certain objects. Therefore, we should aim to reduce the vertex count, since these excessive details may not be noticeable to the player. So we begin by applying all the modifiers generated by the add-on. Let's check them out. Yeah, there are a lot of them just to build this unique shape. So apply to modifier is easy. We just open this menu and click apply, or there is a shortcut Ctrl A. Let's do it for all modifiers that are there. Okay, it is done. And now we need to add a new modifier called decimate. There it is. And we can see the face count here. We will just move the ratio to decrease the number of faces and vertices significantly. Let's do it. Click and drag. Yeah, it's going down. More, even more. No, not 2, definitely. There. 600 something. That could be okay. Yeah, that is great. It still looks like a rock, and we managed to reduce the number of vertices from almost 50,000 to only 668. Perfect. Now we need to ensure that the material we apply in Godot accurately aligns with the surfaces of the asteroids. There is one additional aspect we need to address for this. Let's click UV editing, and here there is the menu UV and the option Smart UV Project. Let's open it and just click OK with default parameters. And we can see that the faces are now correctly applied to the texture. Just don't be confused that there is no texture at all. The model will be exported with face mapping even without the texture, and we will assign the material in Godot. So we can save the model and export it just like we did before as GLTF 2.0. This time it's not necessary to apply modifiers because there are no modifiers at all, but maybe it might be safe to do that. And yes, we will export this model as asteroid GLB. There we go. Let's get back to Godot. And before we import the asteroid, it's necessary to decide what kind of 3D object we want to make out of that. There are basically three options, because character body 3D, which we used for the ship, is out of question. It wouldn't be suitable. Let's review this option. First, rigid body 3D. It is a node used to simulate physics for objects that have mass and can move in 3D space. It applies forces, impulses and gravity to objects, and as we mentioned before, we don't have any gravity in our game, and we probably won't use too many forces because we plan to calculate coordinates and movement by our scripts. So we won't choose rigid body 3D. Second one, static body 3D. It's a node used for static objects that don't move and have infinite mass. We already use this node for static boundaries, which is actually the typical use case. However, we can also utilize this node for enemy objects like asteroids by manipulating their positions in the script to simulate movement. So we can definitely consider this possibility. And the third one, area 3D. It's a node that defines an area in 3D space and can detect nearby objects and collisions within that area. It doesn't have a mass or apply physics forces to objects. Additionally, we can employ similar approach to move the objects around the game area, similar to what we proposed to for static body 3D. So this characteristic just makes area 3D another suitable option for our enemy objects. Okay, so what to choose? Honestly, the decision between static body 3D and area 3D is subjective and a matter of personal preference. In my case, I ultimately opted for area 3D because I had already incorporated static body 3D elsewhere in the game, and I was keen to explore and compare the advantages and disadvantages of different object types by testing as many variations as possible. So let's click back to Godot and import the exported asteroid model. It should be here. Wait a minute. Let's click models, and there it is. Let's drag it to the models folder, and we have the asteroid here. And just like before, let's right click and new inherited scene. Here it is. Let's right click the root node and change its type to area 3D as suggested. Done. And again, there is a warning sign next to it because we don't have a collision shape. Let's right click this node and add child node collision shape 3D. In this case, we will assign a spherical shape, and let's make it a bit bigger. That's too much. Let's try 1.5 meter. Yeah, sure, why not? It's not necessary to be absolutely accurate, and this could be sufficient for a space shooter. What we need now is a material for the asteroid, so it would look like a rock. Let's click this node, it's Mesh Instance 3D, and we will assign a material to this surface material override. But we don't have a material yet, so let's open the material maker, and this time I will find something like asteroid. Yeah, here it is. Looks pretty nice. And again, just like before, let's decrease the size of the final texture and export the material for Godot 4 standard, and to the same folder. We'll call it asteroid. Save. Perfect. Let's close it. And now we can import all these three files related to asteroid material to the materials folder. There it goes. Very well. Let's open surface material override property and drag the asteroid material there. Nice. Looks like asteroid, doesn't it? Even with the low number of vertices. Great. Now we can save the new scene, Ctrl S, to the folder scenes as asteroid tscn. Done. Let's assign a script to the asteroid node. And because we plan to share the script across all kinds of enemies, we will call it enemy GD. Create it. Let's select the root node again to open it in the inspector and click to the node tab to create our first signal, which is important for collision detection and other things that would be closely related to the mechanics of our game. What we are interested now is the signal area entered, because we want to detect when our ship or a bullet from a gun hits the asteroid. So we'll just double click area entered and the dialog opens. We can keep all the default parameters and just click connect, and we can see that a new function on area entered was generated in our script, and it shows that it's connected to the signal. The same indication can be seen in the scene panel here. Okay. Now, something about the theory of programming. We want to keep the clean code principle, so we will adopt the pattern of composition over inheritance and incorporate a generic enemy behavior into the script named lifecycle GD, which will be injected to enemy GD as a property. This approach has many advantages because it will enable us to apply this behavior to any enemy type, even those that do not inherit from Area 3D. So if, for example, in the future we decide to create some enemies as rigid body 3D or static body 3D or anything else, we can still inject the same behavior script into them and it would work. The reason is that Godot does not support multiple inheritance, so making this the most viable approach. Just don't be alarmed if you never heard of the composition or the inheritance. In the context of this tutorial, it is advisable to view this approach as the recommended method for preventing excessively complex classes and ensuring the game remains easily extensible in the future. So let's add some code to enemy GD. First, we will create a class name because it will be very useful to refer to this class from other parts of the code by its name. This is actually a non-mandatory parameter, but we will use it many times. And we, as I mentioned, we will inject the lifecycle. Lifecycle is lifecycle new. This class doesn't exist yet, so Godot will show an error, but we can ignore it for now. And again, as usual, we will create our init function that would be called from the main script, function init, root node, and spawn. This is a specific variable which I will explain later. For now it will be empty because we will just instantiate asteroids to make sure that it works, and later we will employ some behavior to them. And from this init function we will call it lifecycle init root node self spawn. Again, it doesn't exist yet, so there are still some errors, but this is fine. Ready is not necessary in this case. And process definitely is necessary, and we will simply pass the process function to the lifecycle script. Lifecycle process self delta, just like we did with the stars, if you remember. And the last thing, on area entered, we don't have any collision detection yet, so we will just add a simple debug message here. When the collision detection happens, the script would print just name of the area to this console, so we can verify that the code works. Okay, let's create the basic version of lifecycle in our folder scenes, where we also have the script enemy GD. Right click, create new script lifecycle and create. Okay, where it is? Here. Let's open it, delete the unnecessary code and make the implementation. Okay, the name is required because we already used the name in the script enemy GD. Let's define the variables. This is just a shortcut for an empty dictionary, empty map. This will be necessary to determine what kind of behavior should be triggered based on the time that elapsed since the object initialization. And our current direction, so we know how to move this object and how to rotate it. And how fast it should move. Let's do the functions, func init, which we already call from the enemy GD script. So it needs these parameters: root node, enemy, and spawn. I use the underscore because we already have the variable spawn here, so Godot wouldn't complain about variable shading. Spawn is spawn. Now enemy, which is the object from enemy GD, as we passed as self. Enemy translate. Spawn chords. As you can see, the dictionary is empty, so we only expect that it will contain the key chords and some value. For now, it can stay as it is. Enemy scale object local. This is necessary to create, for example, different versions of asteroids with different sizes, so we don't have all of them exactly the same. Current direction would be defined by spawn direction. Speed equals current direction length. Yeah, this is something I implemented in this specific game. The bigger the vector is, vector of the direction, the higher speed should be assigned to the object. It is necessary to do it this way, but I found it just the simplest way to implement that. And current rotation, spawn rotation. Okay, so much for the initialization. Func process. Okay, so we need to calculate the elapsed time, which is just simply by adding the current delta value. Enemy global position x increased by current direction x multiplied by delta, and the same for the z coordination, current direction z by delta. Logically, we don't use y here because we know that the y coordinate is always 0. We are only moving the objects in the xz plane. And now some objects don't rotate, so we just check if the rotation vector is not a 0 vector. If current rotation is not vector 3, 0, let's rotate it along all three axes. Enemy rotate x, current rotation x multiplied by delta, and we'll do the same for y and z. So copy, paste, some extra tabs here, and rotate y, rotate z, current rotation y, current rotation z. Okay, and last thing we need to do is to remove this enemy object if it just makes it beyond the boundary or after some time, because we cannot simply rely on the boundaries. Some enemies will start their life cycle outside the boundary and just enter the scene from the top, from the side, and so on. So let's do a simple trick. If elapsed time is greater than, let's say, 20 seconds, that should be enough for any enemy objects to enter the scene, and not game manager is in boundary. This is the function we created in one of the previous videos, and now we can finally use it. Let's get rid of this object Q3. Okay. Control S to save. Now let's open Game Manager and create a new function which will call spawn asteroids. But before we do that, we need to insert the asteroid scene into this. So let's just drag it here and add the annotation and variable declaration. Already var asteroid scene. Okay. Now we will add the function. So func spawn asteroids. Again, we need to assign them as child nodes of the root node, so we need to pass the reference to the root node. And let's say we will add 5 asteroids to test it. For I in 5. And now we will define the spawn dictionary, which we referred to in the lifecycle script. Spawn is, so there were coordinates, coords, vector 3 and minus 40 plus e multiplied by 20, 0, y is always 0 as we know, and let's say negative 30, which is in fact our top boundary, so asteroids should spawn at the top of the viewport. Sorry, I forgot to add a comma. Now scale as I said, we want different asteroids, so we will just make some random numbers here. And just to make our life a bit easier, before we do that, let's add a new global function to the utils GD. The function would be called func get random vector 3 in range from 2. And we simply return a new vector 3 with these parameters: randf range from 2, and do this for all 3 parts of the vector. There it goes. Good. Control S to save, get back to game manager, and now we can call utils get random vector 3 in range, random vector 3 in range, and let's say 1 and 4. That would be the random size of the asteroid. Now we need to set direction. Vector 3, 0, 0, randf range 5, 15, for instance. What does it mean? It means that the x direction would be always 0, so all asteroids will just go from top to bottom. And last thing, rotation. Asteroids usually rotate, so we want to do that in our game as well. And again, we want some random rotation. Get random vector in range and 0.1 and 1. That could be okay. Very well. And finally, we need to call this function from our main script here in ready. So let's add it, for example, here, game manager, spawn asteroids, and reference to the script self. And one last thing, we want to keep track of enemy objects as well. That's exactly why we created a debug overlay. So we will add the asteroid object to the group enemy. Let's do it now. And we need to add this enemy objects to debug overlay, where it is here. So let's define var enemy count is 0, and let's copy this and paste enemy count enemy, and this plus enemies plus str enemy count plus end of line. Okay, well, let's check it out. Okay, nothing happened yet, so there must be something wrong. Let me find it out. Okay, I found it, of course. This is what happens when you work too fast and don't check your work. We prepared everything correctly, maybe except this thing. There was a typo, so I added D. But I completely forgot to instantiate the asteroid scene and add it to the scene, to the main scene. So I added these 3 lines: create an instance of the asteroid scene, assign correct parameters to it, and finally add it to the root node. now, if we run the game, we should see 5 different asteroids going from the top to bottom and rotate. There it is. There are no collisions yet, of course, but otherwise it seems that they are behaving correctly. You can also observe the number of enemies here in the debug overlay. And after this hard-coded 20 seconds, which can be, yeah, it already happened, and all enemies have been removed from the node tree. So yes, I can say it works.